Welcome to Chapter 4. Chapter 4 uses what we have learned in Chapter 2 and 3. So you'll notice our essential question is, how can you use a graph to solve a quadratic equation? So in Chapter 2, we learned about solving a quadratic equation. Remember, we had something that looked like this, and we would factor this and then set each of those equal to 0 to get our answer. That -3 and -1 were our solutions. Remember, at that time I said we had 3 different names: solutions, roots, I'll write them down, solutions, roots, and zeros. All the same thing. All the same thing. Okay? What it means is that these are the 2 values of x that could go in there and make it a true statement. Okay? When we graph, which we learned how to do in Chapter 3, we can visually see our answer. So, and more often than not, on a graph, we call it our roots. Honestly, I don't know why there's so many different names and why it's a different name depending on how you look at it or how you get it. I don't know, because math is weird, I guess. So let's first write down these steps, okay? So pause, write this down. So, and you can use your notes, of course, on quizzes and tests, so write it down so you don't have to remember this stuff, okay? You just have to be able to do it. So first we have to get it into, so it looks like this. And when we get to examples, you'll see what we mean by that, okay? Because it's going to not look like that to start, but it will be very simple to get it to look like that. And then you need to graph it, just like we did in Chapter 3, okay? Where we make a table, or we use -b/2a. We'll talk about that when we get to examples, I promise. And then we're going to find the x-intercepts, okay? Well, remember, we know about y-intercepts. They're the ones that where our graph crosses the y-axis. Well, the x-intercepts are where the graph crosses the x-axis, okay? Just a little note, and I think we talk about this later, I don't know. Actually, maybe we don't. You could have 2, 1, or none, okay? You will never have 5. You will only ever have 2, 1, or none, okay, depending on where the graph is. And we will talk about that as we go through these examples, okay? And this is just talking about the different names, okay? So we need to graph this, but first we have to get it into that standard form, which means we need to move that 3. So we need to subtract 3 from both sides so that we end up with 0 over there on the right. -3 equals 0. Okay? And then we can make our table like we're used to. The only difference is that we're going to start with the same 5, okay? But we might end up having to add some this end, like -3, -4, or this end, +3, +4. And we'll talk about that as we go, about why we would need to do that, okay? So, we could also do it using this, right? Okay, but this is not always going to be the easiest way to do it, okay? The table is also not necessarily always going to be the easiest way. You can do it whichever way you want, okay? We just have to be very careful when we do it with using this vertex formula. It's not always easy to find the right points that we're looking for. So you might end up having to go back and do some table anyway, okay? But we'll go back and forth as we do the example so I can kind of show you what I'm talking about, okay? But we're going to make a table for this one. So let's put our -2 into our equation here like we did last week, okay? So -2 squared is 4, plus 2 times -2 is -4, so that's 0, -3, so we've got -3 there, okay? To save a little bit of time in the video, I'm actually just going to put some numbers in there for you. So you'll see that, remember, we're always trying to figure out where is our vertex, where are we going up and then down, where are we changing direction. So that would be right here. Here we're going down to -4 and then we turn around. So our -3's kind of meet and we get that point right there. That's going to be our vertex, okay? So if you had done this, used that, you would have ended up with that as our vertex, okay? Notice a couple of things. Notice that our vertex is here, and then we have these 3, and we only have going down, and we only have 1 going up, right? That is an indication that you need to keep finding points, okay? So here's what you're really looking for, though. You really want to find your points where y equals 0. That's what you're really needing, because that's the answer to the question, okay? So we have 1 here, and we should have 1 on the other side of the vertex. So let's try -3 and see what happens. So we put -3 in there. -3 squared is 9, -6 minus 3, that's 0, right? So now we have a second one with a 0. Now again, you won't always have a second one with a 0, okay? If you've found, 5, 6, 7 numbers here and you only have 1 with a 0 or none with a 0, chances are good that there is no solution. Okay, so you're not going to, remember, you're only going to ever find 2, 1, or 0. Okay, and that's when you would say, hey, Miss Emig, am I doing this right, or does this one not have any solutions? Okay, most of the ones we do when we're graphing will have solutions, though, to make it easier on us. Okay, so then I'm going to erase my math here because we need to put those points on a graph. Okay. And there's our graph. Okay, so let's put these points on a graph. So -3, 1, 2, 3, 0, -2, -3, oops. -1, -4, 0, -3, and 1, 0, and then let's put the 2, 5 on there just because we can. Okay, so there we have a parabola, kind of lopsided because my graph is lopsided. Okay, here's what you're looking for. Those points where your graph hits the x-axis. Those are your answers. Okay. We know, because we did the table version, that we have it this way. Okay, so our answers are -3, 0, and 1, 0. Okay, that is where we hit our x-axis. Now, some of you I know are going to say, well, if we do it in the table and we know those are answers, do we have to graph? Yes, because you might have messed up. And the way to know that you messed up is by graphing it, and if you get a straight line or something like that, then you would know. Okay, so yes, you do still have to graph the points. Okay, let's try another one. So let's start. We have to subtract our 8 on both sides. So that, I'm going to write it over here. So that gives us x squared plus 2x minus 8 equals 0. Okay. So let's do this one using the -b/2a formula. So that means we're going to put, remember this is b, this is c, this is a, which is really a 1, right? So we're going to do -2/2 times 1. That 2 is always a 2, don't forget that. So that means we get -1. Okay, so that's that's x. So x equals -1. Hopefully it sounds familiar from chapter 3. And then we're going to put that in there. So -1 squared plus 2 times -1 minus 8. I'm going to put this actually in my calculator because I don't really trust my brain right now. So -1 squared plus 2 times -1 minus 8. And that's going to give us negative 9. So what that means is that our vertex, so y equals, so our vertex is negative 1, negative 9. Okay, so let's graph and see if we can figure out what our zeros are. Oh, I should have had more on there, huh? 6, 7, 8, 9. Okay. And we know it's going to go up, so we don't have to go any lower than that, right? So, let's use green. So negative 1, negative 9, that's our vertex, okay? And then we know that we have a y-intercept at negative 8, okay? And then we can put on our axis of symmetry, right? And so we can go over 1 to get another point right there, okay? And then that's how we've graphed, right? But here's the thing, we don't know actually, by doing it this way, we don't know where these hit exactly, okay? So that's why we want to use the method of the table, okay? Because a lot of times using our negative b over 2a isn't going to give us what we're looking for easily, and we would still have to make a table. So from here, we could make a table that we know it's going to be like in here somewhere, right? So we could do negative 3 and see what we get. Okay, so if we put negative 3 squared plus 2 times negative 3 minus 8, we get negative 5. Okay, well that's here, right? So that means it's actually way over here. So maybe let's try negative 5 and see what we get. So negative 5 squared plus 2 times negative 5 minus 8 gives us positive 7. So that one's going to be over here. So where do you think it probably might be? Let's try in here. So negative 4 squared plus 2 times negative 4 minus 8 gives us 0. So negative 4, 0. Okay? So it's a little bit of trial and error if you do it this way, which isn't a big deal. Okay? So that's our point right there. Okay, so here's where it's easy though. Once you find one of them, you can find the other one. So because this one is 1, 2, 3 away from our axis of symmetry, right? So that means this one's going to be 1, 2, 3 away from our axis of symmetry. So our second one, so we've got negative 4, 0, and then our second one will be 2, 0. And you can check that if you want. Put it in the calculator, 2 squared plus 2 times 2 minus 8. Hey, that gives us 0. You can check it once you know, right? So, whichever way works for you, okay, I'm going to do a couple more examples and I will attempt to do them both ways. Okay, I want to do this one with the negative b over 2a, partly because this is actually the second time I've made this video. And the first time I totally messed this problem up doing it the other way. So I'm going to try doing it the negative b 2a and see if that makes my brain work better. So we have, this is our b, whoops, b. 1 is our a, right? So we've got negative 8 over 2 times 1. Be very careful. I'm seeing a lot when I'm watching people work that you're just always assuming this is a 1. But sometimes it's not a 1. Okay, so be careful with that. That's 2 times 1. So negative 8 divided by 2 is negative 4, but negative. So we've got positive 4. So our x equals positive 4. Okay, so let's put that into our equation here. So 4 squared minus 8 times 4 plus 16. Hold on, let me back up because I didn't actually do that, did I? Right, to make our new equation, sorry. Plus 16, there we go. So now we can put that 4 in there. So sorry about that. So 4 squared minus 8 times 4 plus 16 gives us 0. So that's, so our y-intercept, I mean, sorry, I don't know what I'm saying. Our vertex is 4, 0. Okay, so let's graph that. Okay, so 4, 0, so 4, 0, that's our vertex, right? And then our y-intercept is 6 plus 6, oh, sorry, it's over here, plus 16. Well, let me put a whole lot more thingies up here, right? So that means that we've got a parabola that goes like this, right? Ish, okay? Well, guess what? How many times does it hit the x-axis? Just that one time. This is one of those cases where we have one of our solutions. We only have one solution, and it happens to be the vertex. Okay? So you might want to make a mental note or even write down a note that says, if your vertex has a y of 0, that is your one and only solution. So your actual solution is 4, 0, and that's it. That is your one and only solution. Okay? So in this case, this would be why this would be easier. Okay? For the most part, starting here with this vertex formula is going to be easier. Okay? But some of us are not comfortable with that vertex formula. Okay? But you also, if you don't use the vertex formula, you might end up with a really, really big table in order to get the points that are on the x-axis. Okay? So let's try another one. I'm going to use negative b over 2a again, okay, because I kind of want you to get the feeling for that, especially those of you that didn't perfect it in chapter 3. Okay, so we're going to do negative b over 2a. So let me do this first. We got to add that 4 to both sides. Okay, sometimes you'll have to, sometimes it'll already be over there and equal to 0, okay, because this is what you have to see. Your trinomial equal to 0. If it's not equal to 0, then you can't do this. Okay, so this is our b, this is our 1 is our a, so we've got negative 4 over 2 times 1, that's times 2, 4 divided by 2 is 2, negative, so x equals negative 2, right? So let's put it back in to find our y. So we're going to do negative 2 squared plus 4 times negative 2 plus 4. And I'm going to put it in my calculator here. I think it's, I don't know what it is. Negative 2 squared plus 4 times negative 2 plus 4. It is 0. So our vertex is negative 2, 0. Okay. So again, on our graph, we can, oops, let me put some tick marks there. Those are some crazy tick marks over there, sorry. So let's graph our vertex, negative 2, 0. Notice that it's on the x-axis. That's going to be our one and only actual answer to the question about solving it, right? But to finish our graphing, we have a y-intercept of 4, so this one actually will fit on there. Whoops. We make our axis of symmetry, and if you don't actually draw the axis of symmetry, that's okay. 1, 2, and up. There we go. And so we have a, whoops, pretty parabola, if I can draw, which gives us that we have one solution because it's sitting on the x-axis. Let's do one more equation because it looks a little bit different. Okay. Notice we have just the x squared over here. Well, it's negative x squared. And then we have 2x and 4 over here. So you need to make this equal to 0. The easiest thing and best thing to do to make it all positive is to add the x squared to both sides. So then we've got 0 equals x squared plus 2x plus 4, and it's the same thing we've been doing. Okay, so let's try the negative b over 2a, okay, because in the end it's probably going to be a little bit less work for us. So, and it's good practice because you'll use that again later. So, negative 2 over 2 times 1, right? Because this is b and this is a. So oops, that should be 1, not an a. So 2 divided by 2 is 1, so negative 1. So x equals negative 1. So let's put that in. Negative 1 squared plus 2 times negative 1 plus 4 gives us, I think, 1, but no, 2. Let me just double check here. Negative 1 squared plus 2 times negative 1 plus 4, 3. I was totally wrong. It's a good thing I put it in the calculator, right? So y equals 3. So our vertex is negative 1, 3. Okay? Notice when we start graphing this is negative, so that means it's going to go upside down, right? Keep that in mind as we're graphing. Okay? So let's make ourselves a graph. Okay, and then put our vertex on there. Haven't used blue yet on this problem. Negative 1, positive 3. Okay, and then we have a oh, I'm sorry, I lied. This is negative, but we added it, so it's positive here, so it is going to go up. Sorry. And so our y-intercept is positive 4. And then go over 1 and up 1, and that is our other point, right? You will notice here that we don't ever touch the x-axis. It's all up here above the x-axis. So that means there is no solution. Okay, it's not 0 or anything. It means that there are no solutions, no roots, however you want to say that. Okay? Yay. So we'll do some more examples from the homework in class, and let me know when you have questions.